All right, we're going to continue with our test 4 review. And in this video, we're going to do questions 4, 5, and 6. This one here says, this question 4, it says that the graph of the function y equals log base a of x goes through the point 216, 3. And we want to know what a is. We just want to know what the base of the logarithm is, okay? We know that the logarithm passes through the point x, the x value is 216 and the y value is 3. And since the y value is 3, we're going to put a 3 here where the y is. Because the x value is 216, we're going to put a 216 here where the x is. So we're going to write 3 is equal to log base a of 216. And we're just trying to solve for a here, okay? Now there's a couple ways we can do this. We can solve it like a logarithmic equation, and if you did that, it actually wouldn't help, because look at this. We would have to do a to the we could, yeah, I guess we could, but we'd wind up bringing in a logarithm again. It's a little messy. Really, all we have to do here is convert it into an exponential. So if we were to convert this into an exponential, another way of writing it is that log base a of 216 is equal to 3. And now this probably looks a little more familiar to you. And we can say that a to the power of 3 is equal to 216. So we can rewrite this as a to the power of 3 is equal to 216. And so now we just need to figure out, well, what to the power of 3 is equal to 216? That's one way of doing it, and there is an answer. Another way of doing it is to put each side in parentheses and raise each side to the 1/3 power, because the 1/3 power will cancel this 3 here. So if we raise both sides to the 1/3 power, 1/3 times 3 is 1, so we have a to the first power, or just a, and that's equal to 216 to the 1/3 power, which we can go ahead and do in a calculator. So here we have the calculator. So we do 216 to the power of 1/3. If we press enter, we get 6. So the answer is 6. And we knew that already, because we know that 6 to the 3rd power is equal to 216. But just in case you're not good at that, you can still do it in a calculator. So a is equal to 6, and that is our final answer for this question. All right, this is question 5. There's a couple ways that we can do this. We have log base 3 of 243 is equal to blank, okay? One way you could do this is you could put a k in here as your answer, and just say, well, I know that whatever k is, that's going to be my answer, okay? And so this is going to be 3 to, if we then convert it, it's 3 to the power of k equals 243. 243. That's one way to do this. And then we can say, well, what 3 to what power is equal to 243? Well, we know this one. We know that 3 to the 5th power is 243, and that means that k must be equal to 5, okay? So that's one way that we can do this. We know the answer is 5. There's another way to do this. We could actually do this with the change of base, because if we take log base 3 of 243, we know that this can be written as a logarithm using the change of base formula. We can write this as the natural log of 243 divided by the natural log of 3, which we can now just put into a calculator. So we can press natural log 243 close parenthesis divided by the natural log of 3, and you can see that the answer is indeed 5. And so that's how we do question 5. All right, this is question 6, and you can see in this question we're told that the graph of the function f of x, and which is log base 5 of x plus 4 and then quantity minus 9. And we want to know how to get the graph if the graph of g of x is just log base 5 of x. So f of x is a transformation of g of x, and we want to know what kind of transformation it is. which direction are we shifted, and by how far? Well, you can see in f of x, it has x plus 4 on the inside. So we know it's shifting by 4 units, but is this plus telling us to go to the left or the right? Well, remember, when it's with an x, it's the opposite. So if we have a positive, it's a negative shift. If we have a negative, it's a positive shift. So this says x plus 4. So that's a plus 4 shift on x. And so it's the opposite of that. It's going to be a minus 4 shift. Minus is to the left. So that's a leftward shift by 4 units. And then if we go to the very end of the function, it says minus 9. And we know that whatever is at the end of the function, that tells us the vertical shift. So it's a minus 9 vertical shift. So that's down by 9 units. Okay. Then we want to know what is the domain of this function. The domain of a logarithmic function is the same as the range of an exponential function. So we know that it's going to start at 0 and include 0 and go up to infinity. But this one is actually not starting at 0 because it has a leftward shift by 4 units. If we take 0 and shift it left 4, well, what's 4 units to the left of 0? That's negative 4. And therefore, this domain is going to be, instead of 0 to infinity, it's going to be negative 4 to infinity. Okay? So negative 4. Why? Because it's shifted 4 units to the left. Okay? And then we're asked about the range. Well, the range of a logarithm is the same as the the domain of an exponential. And so the domain of an exponential is negative infinity to positive infinity. That's all numbers. And so the range of a logarithm is all numbers. Negative infinity to positive infinity. And that's how we do question 6.